Hi, Eugene here. This is a video to go through the oscilloscope on two ways to do resets and another way to calibrate the probes. And to be honest, it's partially for you and partially for me. Because what ends up happening is I'll be a year later and then I'll have to use the oscilloscope and I'll forget what I'm supposed to do with it. So let's continue on and I'll show you how I do it.
And here's my RIGOL DS1054Z. It's, of course, the oscilloscope. And so that there's two different ways of doing the reset. So right now I have it so that they're a little bit out, which is good because whatever test you're going to be doing, it'll have its own settings. But to do just a screen reset, what we do is there's three buttons here, 1, 2, and 3. And each one of these you just push on them, 2, 3, and it resets the screen back to its default, which is good for some tasks. But sometimes you want to reset even the settings that are on the inside and reset the screen itself. So when you're doing that, what you do is you actually, there's up here, there's a storage button in the upper right-hand corner. You push that, and then this here, it goes to default, and you push the blue button, and give it about 5 seconds or so, and it's going to reset the internals, and it's also going to be resetting the screen. So we can tell that it's done now because it's actually just went to channel 1 and channel 2 is off. But I do have two different probes. So what we'll do is I'm going to turn on channel 2 just by pressing the button so it's lit up. So that's good. They're both on there. And now what I can do is let's go and do the calibration. So on the calibration, there's actually a small little set screw here. And of course, there's a small screwdriver that comes with your oscilloscope. So what we'll do is we're going to be adjusting that set screw, but on the oscilloscope here, it actually has a generator, and there's a top portion and a bottom portion. So the top part is the signal generator. So you pull it out, you connect the generator, and you can see there's something happening there. And then you connect the alligator clip on the bottom. Similarly, you take probe B, which is channel 2, connect that up, and then you put the alligator clip on the bottom. So it's starting to get a little bit crowded there. So now we've got it connected up, but we're not getting the pattern that we want because we can't really see the nice square waves yet. So the way to get the square wave is we actually have to push auto, and it'll automatically detect it and make it the way that we want. Again, it'll probably take about 5 seconds or so. And now we got some some nice looking waves. So we've got the yellow one, which is channel 1. We've got the blue one, which is channel 2. So a square wave, when we take a look at the manual, there's three different types. So there's an overcompensated, which is probably similar to the yellow one. And then there's an undercompensated, which is kind of close to the bottom one. You can see that this has a line that's kind of lagging on this side. And then the perfectly compensated. That's where the square wave looks really, really nice and crisp and has nice 90-degree edges on it. So what I'll do is I'm going to take that screwdriver and first I'm going to do probe number 1, which is the yellow one. And I'm going to turn that silver screw, and you just have to be gentle with it. And you can start to see how the yellow line is moving. So you want to make it so that it's really nice and parallel and that it looks just about 90 degree lines between here, 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 and here. So that looks really good. We'll say that's calibrated. Now we want to do the same for channel 2. So I'll grab the channel 2 probe. I'll find that set screw. And we'll adjust it. And let me find line up the set screw with the screwdriver. All right, starting to move a little bit. And right about there. Okay, so now we have both probes calibrated. We have a nice sine or a nice square wave that's generated by the oscilloscope. Everything is looking nice and square on the top and on the bottom. So now we're ready to go on to the next phase where we can do whatever testing that we'd like to do. But at least we know now that the oscilloscope is ready to go. All right, thanks a bunch and talk to you later.